Hey everyone, thank you all for joining us. My name is Wyatt Gorman. I'm the High Performance Computing Solutions Manager here at Google Cloud. And today, presenting with me, I have Annie.
Hi everyone, I'm Annie Ma-Weaver. I'm the Product Manager for High Performance Computing, and I'm really excited to be here.
Awesome. So we have a few topics for you today. We're going to level set, first of all, about what HPC is and why it's important to several industries. Second, how we're helping HPC customers thrive on Google Cloud. Third, what we're doing to advance the HPC state of the art, on Google Cloud. And then finally, how you can go and deploy your own HPC environments end to end on Google. So to get started, let's talk about what HPC is and why it's so important for so many different industries. So organizations across many different industries are really facing tremendous growth of data and demand to process that data, right? This is just a few industries, but you've seen advances in medicine recently that mean more new drugs are coming to market every year. And in fact, the FDA is approving more new drugs each year since 2010 than they had in any previous decade. So, you see it in drug discovery, you see it in genomics, you see it in brain simulations and healthcare life sciences. In financial services, the variable markets that we've been seeing over maybe the last few years, combined with increased regulatory requirements and compliance requirements, has really driven the financial institutions that we rely on to re-examine the tools and the mechanisms they have to process that data, right, to do things like risk analysis. And then manufacturing industries are really struggling to put data to use in production, right? In a lot of industries, I should say, manufacturing industries have found that they can't really use data at scale in their manufacturing. And this, obviously doesn't cover public sector or media and entertainment, retail, or a number of other industries where HPC is growing very, very quickly to meet the demands of all of these factors. So why are people looking at HPC, right? HPC offers business leaders the opportunity to speed up the processing of the deluge of data that they're seeing and to get the results that they're looking for faster while still controlling costs, right? We were just in a meeting where I heard yet again, I've heard this from so many customers, that they had a decision to make at some point between building out an on-premises HPC infrastructure to solve one of their tasks. This was a financial services industry, so to do the risk analysis that they needed for the regulatory compliance, it would have cost about $20 million to build out an HPC system. That would have lasted them maybe 5 or 7 years, but would have done the task. On the other hand, they could run that in Google Cloud's HPC for $500,000 a year. Right, so that kind of decision is easy to make when that's the mathematics that you're looking at, right? Scalability, HPC does what it does by scaling workloads across multiple resources, by scaling up and out, and distributing that work then across all of those resources and parallelizing that work to speed up the work being done while maintaining cost. However, the idea of implementing HPC on premises has its limitations, right? This is what people have been doing for years, and we've really hit the limits, I think. The systems that people design for HPC systems are built in fixed amounts, right? So you decide at some point you want 100,000 cores, 10,000 cores, whatever it is, however many GPUs. And that's the system that you go and procure and install, and it takes up to a year to go through the process of putting out an RFP if you do that, talking with vendors, architecting your system, getting it built and shipped, and then doing acceptance testing, right? Some of the really large systems take a long, long time to get approved. And they're built on this multi-year refresh schedule, right? So you have every 5 or 7 years, you can look at a new set of hardware, whereas you might already be 2 or 3 generations out of date on the latest GPUs, for example. And users in a shared system typically wait behind other users, multiple other users in a queue, right, for access to those resources, because it's very expensive to build out an HPC system to handle all of the work that you might possibly need that system to do, right? And we'll talk about a couple users and how they've seen that. But waiting behind other users limits the amount of work you can do, limits time to innovation, time to results for manufacturing, right? And in industries where you're trying to come to market with something first, that can be devastating, right? Not being able to get your results in the time that you need. And when organizations look at migrating their workloads to the cloud, it gets sometimes even more paralyzing, right? The amount of work that you need to do to move to the cloud, the potential cost, not just of the move, but of re-platforming any tools and training users can be daunting, right? Can seem intimidating. Luckily for everyone here and everyone else, Google Cloud has an HPC platform that has a full spectrum of easy-to-use products, tools, and integrations for you to run your HPC workloads really, really easily and cost-efficiently on Google Cloud. So that includes our infrastructure first on the left with the latest processors and accelerators, reliability and security built in, high-performance storage options, which we'll talk a little bit more about, and high-throughput, low-latency networking between VMs. On top of that, we layer our platform, right? Our HPC tools and services. This covers things like our simple batch service, which is our managed scheduler for simple batch workloads. That covers the Google Kubernetes engine that we have for containerized workloads. And we'll talk a little bit about how that's come up to speed for HPC, and it's not just a web serving platform anymore. And it includes our Cloud HPC Toolkit, which we'll talk about more as well. And finally, we support a broad partner ecosystem of partners across ISVs, system providers, system software providers, so like schedulers and storage, and then system integrators as well to make sure that customers can bring the software that they're used to Google Cloud without the need to re-platform if it doesn't make sense, and that they have the partners there to help them implement that. So, how have we helped users of Google Cloud HPC platform actually thrive on Google Cloud, right? To answer that question, I want to look at 3 industries and 3 different stories from those industries. So first is higher education, right, academia. The University of California is a great example, the University of California, Riverside is a great example where researchers were facing the very common challenge in HPC of high demand for limited resources, right? I mentioned queuing behind other users, and that's exactly what they face. They also face the challenge of a traditional academic research environment where multiple researchers have multiple interests, multiple jobs, and you can never really tell how much anyone's going to need at any one time or when they're going to need it, right? They might just show up, you might get a new PI, and this happens all the time where people bring in a new principal investigator and they get a lot of money and they need a lot of compute all of a sudden, right? So what UC Riverside did was they combined 2 key components to solve this issue. First is the Cloud HPC Toolkit, which we'll talk about a little bit later. And second is the Google Cloud Public Sector Subscription Agreement. So the Public Sector Subscription Agreement is a fixed cost subscription model for public sector users who are running HPC workloads. And it's specifically built to address the bursty needs of HPC workloads, right? Again, you can never really tell if somebody's going to log in on the weekend and spin up a large job or something like that. So you have to be ready, right, to flex and to respond to customers' needs. And that's really the point of the cloud, of course. But the cost variability associated with that can be challenging, right? Often in academic environments, they're working on fixed grants or multi-year budget timelines, and they can't just flex that cost. So the public sector subscription agreement gives them a fixed cost where you can even go above the predetermined amount of resources that you get with your commitment, and we won't charge you extra for that. So it's specially built for HPC users in the public sector industry. The CIO of UC Riverside has even said that by combining the public sector subscription agreement and the Google Cloud HPC Toolkit, they're able to offer their researchers opportunities that they would not get outside of UC Riverside and without this technology. So we're really proud of that. Computer-aided engineering is another very heavyweight workload in HPC, right? And it covers multiple different workloads, computational fluid dynamics, structural engineering, all these sorts of things you might be a little more familiar with. And it's a workload where the HPC work done can directly impact the time to market for a company, right? Think about your Pixel phone or your car, right? Doing the drop simulations and the crash simulations and making sure that it's safe or it's not going to crack is important before going to market. So being able to do those simulations faster than anyone else is important when you're in a time crunch. So what we did was we partnered with a number of ISVs, but all Terra is one of the key ISVs in the CAE space, and we ran some benchmarks with them on our latest and greatest H3 VMs, which Annie will talk about more. And they found that they were able to speed up the simulation runtimes of one of their most popular CAE applications, Radios, by up to 3x. Versus the last generation of HPC VM types. So that kind of performance improvement for Altair's customers really makes a difference in terms of being able to do work, right? If an engineer had to wait a day to get a simulation done, now they can do 3 in a day, right? That's the kind of difference that we're talking about here. And then finally, drug discovery is, tremendously computationally complex workload in HPC. It requires vast amounts of data and a significant number of iterations over that data in order to do the kind of drug discovery and chemical library sort of screening that they need to do. And Schrödinger is one of our customers. They've been a customer of ours for a long time, but they found the HPC platform at Google Cloud as a perfect source of that computing power that they need. And they've been able to explore more chemical compounds using Google Cloud than they ever have been before. So, opening up the scale and the scope of what customers can do in their own industries by offering them more and better HPC resources is really our goal. And they found that, the request to Google Cloud to spin up tens of thousands of GPUs wasn't an issue. And that really, really helped them do their work. So now that you understand what our customers are doing today and how they're thriving, I'm going to hand it over to Annie to dive into how we're advancing the state of the art with HPC on Google Cloud.
Great. Which button advances? That one. Cool.
Thanks, Annie.
All right. Thanks, Wyatt. Hi, everyone. I am delighted to tell you about our CPUs, GPUs, and storage product announcements. And the reason we find this exciting is that it will help our HPC customers more easily deploy Google Cloud resources to start solving your problems at scale in a cost-performant manner. Our HPC platform consists of 3 layers of cloud infrastructure, deployment, and development. Cloud infrastructure, compute, storage, networking, you know it, you love it. I'm going to tell you more about it. Development includes our built-in development tools, including our communication libraries like Nickel and MPI, and our infrastructure management tooling. Finally, there's deployment, which includes amazing products like the Cloud HPC Toolkit, the HPC VM Image, and Batch. We coordinate offerings across compute, networking, and storage, and work with partners and open source projects to develop end-to-end solutions for your HPC needs. This is a gorgeous slide. I recommend you. I see some people taking pictures. Please do. It's very nice. I like to share some new compute engine virtual machines that are built for HPC. First, Google Compute Engine, or GCE, provides VM families to suit your workload needs, whether they are more general purpose or mission-critical, highly performance-intensive. Our C3 machine series is now generally available. These are built on the Intel 4th generation Xeon, let's see if I can say this, scalable processor codenamed Sapphire Rapids, and are available for our GCE and GKE customers. To further support our customers and advance our commitment to workload optimized infrastructure, we are launching our new H3 virtual machine series. So we actually launched this a couple weeks ago, and I want to see by a show of hands, have you guys heard of this before? Okay. All right. Okay, for those who raise their hands, please come up and you can talk more about it. Okay. So the H3 series is our first machine series that is optimized for HPC. It is again built on Sapphire Rapids and takes advantage of our Google Cloud Custom Intel Infrastructure Processing Unit, or IPU. The H3 is an addition to our Compute Optimized VM family, which includes the C2 and C2Ds. H3 has shown performance improvements over prior generation C2s for a number of key HPC use cases, including molecular dynamics, EDA, weather forecasting, and more. The H3s offer 200 gigabyte per second default low latency networking, which is 2 times the prior generation. It also offers up to 3 times improvement in per node performance, again compared to the C2s. And we're not knocking the C2s, they are phenomenal, but the H3s are truly a step forward. We also have seen 2 times better price performance versus the C2s. And we've worked with leading partners like Altair, Ansys, Parallelworks to create the best experience for HPC customers. And I know Wyatt just talked about some of those benchmarks that we ran with Altair. Next, I want to talk to you about something that is in the news. I'm sure you've heard. You're probably sick of hearing about it, but AI/ML. What are we doing there? So we have the A3 supercomputers, which will be generally available next month. And these supercomputers are purpose-built to train and serve the most advanced machine learning models. And these models, they are powering today's generative AI and large language modeling innovation. I'm sure at this point you've heard about Gen AI and LLM so many times that it could be a drinking game. Here are some key features of the A3s. They are powered on 8 Hopper 100 NVIDIA GPUs, and they show up to 3 times higher performance for AI training versus the prior generation A2s, as well as 10 times network bandwidth increase. The NVIDIA Collective Communications Library, or NCCL, is built for deep learning frameworks like TensorFlow and PyTorch, and is used for multi-node and multi-GPU training. FastSocket is a Google proprietary network transport built for NCCL, and we've seen an increase in network bandwidth speeds using FastSocket because of its ability to decrease contention between multiple TCP connections. In fact, we've seen up to 60% improvement in all reduced throughput. For those interested in setting up a FastSocket environment, you can either use a deep learning VM image or a compute engine public image. Compact placement reduces latency by placing nodes in closer proximity and is well suited for tightly coupled batch workloads. It can be specified at the node, pool, or cluster level. The Queued Resource Manager, or QRM, is a way for customers to request VM instances of scarce resources like GPUs. Once you have put in your request, you'll get either a high confidence response about whether your request can be fulfilled and by when, or an immediate response that your request cannot be fulfilled. This way you can better manage your capacity demands. Next, I'm excited to share an innovative addition to our storage portfolio for HPC. But first, we have the right storage for your processing type, either through our native offerings or our partner integrations. Moving and storing your data on Google Cloud is quick and easy. As I like to say to my 4-year-old, you take care of the logical, let mama worry about the physical. It does not land that well with her. Now I am so pleased to announce the launch of our first-party parallel file system, Parallel Store, built on the Intel Davis storage stack. And for those on the live stream, which I know you are there, I want to say thank you so much to the Parallel Store engineering team. You guys did such great work. We're really proud of you. Parallel Store is semi-scratch with a GCS durable layer, and it will be used to accelerate high-performance applications that require both high-scale and low-latency data access. I want to share with you some benchmark results. In particular, I want to highlight the sub-millisecond latency and the read throughput of up to 6.3 times of AWS FSx for Lustre Scratch baseline. I also want to highlight the high MD ops, which helps support emerging IO patterns and also AI/ML patterns. Parallel Store is now available in private preview, which means that if you're interested in using it, please let us know so that we can make sure that you have access. And actually on that note, I'm going to go back a couple slides to H3 because I forgot to emphasize the most important thing, which is that it is now available in public preview, which means if you want to access it today, you can find it in the Cloud Console. But if you want to start testing, please let us know so we can provision you adequate capacity. And public preview means that it's free of charge for you to use. Now I want to tell you about some ways that you can deploy HPC resources on Google Cloud. Of course, you can build it from scratch yourself, and I know many of you are capable of doing that, but we also recommend that you consider some of the tools here. For those who want to quickly customize and deploy an HPC environment with partner integrations built in, we have the Cloud HPC Toolkit, which I will go into more detail about shortly. GKE is ideal if you want a platform to manage your containerized applications. It gives you the operational power of Kubernetes while maintaining and managing a lot of the underlying components like control plane and nodes for you. Last but not least, Google Cloud Batch. It is a first-party, cloud-native, fully integrated batch scheduler so that you can schedule, queue, and execute resources for your batch processing workloads. All right, let me tell you about one of my favorite products, the Cloud HPC Toolkit. The Cloud HPC Toolkit is a modular, composable collection of resources written in Terraform to help you quickly and easily deploy repeatable turnkey environments that have the Google Cloud HPC best practices built in. The toolkit has 3 key components. First, blueprints, which is exactly what it sounds like, the design for your HPC system. Blueprints can be general purpose, workload specific, or built around a partner solution. Lucky for you, the toolkit comes with a number of example blueprints, which you can use to customize or give you inspiration for building something anew. The blueprints then reference modules that the toolkit supports. Modules break down into categories like storage and schedulers. And the modules then deploy on Google infrastructure to start running your HPC systems. All right, here is an example blueprint or YAML file with about 60 lines of code. Give you a moment to take that in. This is actually what it looks like. I know, everyone is shocked. The blueprint is then used to create a deployment artifact, which is a folder that has about 3,000 to 4,000 lines of code. And that deployment artifact is then used to deploy an HPC system, which can be 40,000 plus lines of code. So for those who are doing the math, you go from a simple YAML file of about 60 lines all the way up to 40,000 plus lines of deployable code. But you don't have to write it. And that's where Toolkit simplifies things. Setting up your HPC cluster, if you had to write all that code yourself, would have taken days and weeks. But now with the Toolkit, you can get that up and running in minutes and hours. Now I'm going to turn it back over to Wyatt, who's going to tell you about some other ways to deploy HPC systems, GKE and batch.
Thanks, Annie.
Yeah.
So just a reminder before I jump into GKE and batch that the Cloud HPC Toolkit is not only capable of deploying Google Compute Engine resources like the Slurm cluster blueprint you saw earlier, but it's also able to deploy Google Kubernetes Engine resources, batch resources, or a number of other resources, single VM, dashboards in our ops suite. There's a number of modules that make it really easy to build an entire end-to-end HPC environment, regardless of the software stack that you're using. So Google Kubernetes Engine is a really great option for running any of your HPC workloads or AI workloads for that matter that are containerized, right? It's not the only option. You can definitely run containers on VMs and that gives you a little bit more flexibility, but GKE is really great for eliminating the need to worry about the infrastructure layer, the security, the maintenance, any of that, right? We've done a lot of work on GKE recently. I think most people are familiar with Kubernetes as a web hosting platform, and in complete honesty, that's definitely what it was until recently. We've done a lot of work over the last year and a half or so to implement a number of features that I'll describe that really change the way you should look at Kubernetes and think about Kubernetes in regards to HPC. So this includes features like Q. So Q is actually a contribution back to the Kubernetes open source, but Q implements the basic concepts that we're familiar with in HPC of jobs, job scheduling, job priorities and dependencies, and job queues. So it allows users to fair share capacity between GKE nodes and node pools, and it lets you implement the things you're used to in HPC environments like job policies per user or per job, like I mentioned, priorities and other similar capabilities that you would expect out of basically any HPC job scheduler. Sharing and optimizing GPUs on GKE is another feature that we've introduced to help optimize the performance of HPC and AI workloads, as well as the utilization, right? Utilization is a very important thing in HPC. And so making sure that you're not leaving, cycles on the table is really important. So we added, features like NVIDIA's multi-instance GPUs that lets you split out a GPU across multiple instances, multi-process service, time sharing between GPUs, and that all allows you to split up and share GPUs better across multiple jobs or multiple users, and just make more efficient use of especially the really large GPUs that we're starting to see more and more of today. Then there's also nickel fast socket, and Annie described what nickel is, so I won't get into the details, but nickel fast socket basically allows you to accelerate those distributed operations like all reduce by up to about 60% in some cases. And that's really important. I'm sure you're familiar with HPC use cases, but also more and more distributed AI training use cases, which oftentimes use a lot of traditional HPC technology. Nickel fast socket works better than ever in a compact placement policy, right? So you saw compact placements earlier. That works for Google Compute Engine as well as Google Kubernetes Engine. And then QRM is also supported in, Queued Resource Management, is also supported in GKE to allow you to ensure that you can have access to the GPU resources on a compact placement policy and make efficient use of them when you need them, right? And you're not, maybe looking around for capacity or waiting for capacity. GKE has also expanded the number of VMs and nodes that they support in a pool. So they actually have 3x the number of 15,000 nodes in a cluster, so 3 times what other managed Kubernetes services provide or allow you to scale up to. And that's really important for customers like Bayer, who are able to run 15 billion genotypes per hour now that they've been able to scale up to this crazy level in GKE. But it's also important for customers like PGS, who are not only able to migrate off of their on-premises traditional Cray-based supercomputer environment, right? Cray is one of the oldest running HPC providers and system providers in the world. And so they moved off of their Cray and Lustre file system environment to Google Cloud, and then they moved to a GKE-based environment with Google Cloud Storage instead of a parallel file system. And in doing so, they built what could be a system that rivals the top systems in the world, right? So there's this top 500 list. And so PGS built themselves a GKE-based supercomputer that really put GKE to the test, and it was awesome to see. They passed 2.8 million vCPUs in a single environment, 180,000 GKE nodes, and if they benchmarked that with the standard HPC benchmark called LinPack, they would have reached about 72 petaflops of computing power. That would have placed them at the top 7, the number 7 top supercomputer in the world at the time, if they had actually taken the time to benchmark it and weren't using it for more important things. But that just goes to demonstrate the scalability and the remarkable power that GKE has now, and that it's not just a web hosting platform anymore. Batch is another great solution for HPC workloads, especially where your primary goal is getting your work done as quickly as possible without having to worry about anything else. So I say that because Batch is our fully managed zero-ops scheduling service built for and by Google. So the zero ops part is important. So it's really designed for users to really easily run their HPC workloads out of the box without needing to understand the complexities of a traditional scheduler environment, right? Have to worry about data too much, and without additional complexity or cost, right? This is a free service on top of the resources that you use. And it's something that supports containers. You could use it without containers, and supports all of our HPC storage options. It's also very tightly integrated, as you can see, with a lot of our first-party and third-party workflow engines. So you can use it with all of our tools like the Toolkit, with our workflows, and our scheduler. Composer will be supported very shortly as well, next month. And almost more importantly is the integrations with the third-party workflow managers. So for anybody who's in the healthcare and life sciences industry, you might be familiar with the Nextflow workflow manager. That is basically one of the most popular workflow managers in really genomics processing, but healthcare and life sciences in general. And so we've built a really tight integration with Nextflow where users of Nextflow can actually deploy directly to batch, just point Nextflow to batch as their endpoint, and without having to even interact with batch or send, configure anything in batch, they can just go and deploy a job directly from Nextflow. So that's the kind of ease and simplicity we're looking to drive with batch, where Cloud HPC Toolkit lets you get in, line by line and edit things and run scripts and configure tuning and maximum configurability. Batch is as simple as it can get, right? So if you have researchers or people who are just looking to get their science done who aren't too concerned about the computer science, batch is where you should send them. There are many ways to build job definitions. So we support everything from simple JSON at the most fundamental level, all the way through to a web-based cloud console where you can go and click through and understand what your options are without having to read through some manuals or whatnot. And moreover, jobs can really be easily visualized in the cloud console there. You can see the top image, which I'm sorry is cut off, has a listing of jobs there. And so you can really easily monitor jobs. And batch will make sure that your jobs run. It'll requeue jobs if there are issues, support Spot, and all of the features that you would expect batch to support out of the box. And despite how simple it is, it's really a feature-rich HPC scheduler, right? So it supports all the features you'd expect, supports high throughput jobs or HTC jobs. It supports tightly coupled jobs like MPI. It supports job retries and priorities, custom VM images, which can be really important for a lot of folks. Regional placement policy, which is key in bulk API, compact placement, QRM, all of these sorts of things that we have talked about throughout the talk, as well as a number of our HPC storage options. And the CSI driver for parallel store will be coming shortly as well. I'm sorry, the CSI driver for GKE will be coming shortly. Yeah, all this work is really part of the HPC strategy that we have overall, and that's been guiding our work for the last several years. And so that's really broken down into 4 key pillars. First is fast and affordable, speaks to the infrastructure, right? The new H3 and A3 VMs, the actual infrastructure that we build, parallel store, and our networking. And making sure that all of those components work really well for HPC workloads, right? So that the CPU works well with the networking and can run MPI applications as quickly as possible. And then that gets into easy and compatible. So that's about our platform, making sure that, I mentioned things like our bulk API that allow you to spin up 1,000 VMs per API call. Those kinds of features that allow you to do the HPC things that you need to do efficiently are what we're aiming to do with our easy and compatible, as well as being compatible with the leading application providers and schedulers and system software providers. And so that gets into partner preferred. We really want, if you go to one of your partners and say, hey, we're looking at moving to the cloud, who would you recommend? We want them to say Google first, right? So we're working with as many partners as we can to ensure that their applications are benchmarked and are qualified and compatible with Google Cloud, and that if, whenever possible, they perform better than other cloud providers and on premises. So you'll see more competitive benchmarks from us soon. That also goes for the schedulers and the storage, as well as the system integrators, right? The folks who you'll bring in to actually help you implement these workloads. And then finally, it's about bringing the best of Google. So that's our industry expertise. We've had customers where we've brought the folks who are building the AlphaFold ML models or the deep variant models. We bring them into the conversation, right? We have EDA customers where we bring the folks who are designing our TPU chips to them and say, share how you run on Google Cloud with our customers. So that kind of industry expertise, we definitely want to bring to you and make sure that you can learn from us and that we learn from you at the same time. Leading ML and data analytics tools, just a brief idea of this. You can dump all of your job scheduler logs into BigQuery, and then you can use BigQuery ML to understand how a user is running their jobs, when they most frequently run their jobs, what the average cost is. So these are the kinds of ways we're looking to integrate ML and data analytics into our HPC environment, right, top to bottom. And then, making sure that the technology that we bring to bear, whether it's our worldwide network or Kubernetes or other things, really works well for HPC. And so, one of my favorite examples is the LSST project, or it's called now the Vera C. Rubin Observatory. It's the largest telescope in the world. It's built on a mountain in Chile, and they process 20 terabytes of astronomical data a night over the Google Cloud network, off the mountain in Chile, over our worldwide distributed network, up to the US central zone, where it's processed and then distributed out around the world for researchers to examine. So that kind of scientific workload, where you need to transit data, halfway across the world overnight and then distribute it around the rest of the world, is where things like our worldwide network come into play. So with that, I really hope that you enjoyed our talk today. We really hope you enjoy the rest of the week. And we hope you're able to attend some of our other talks that are related to HPC and AI ML workloads. And please go see our partners. We've got a number of great partners down there in the showcase. And definitely go visit those puppies. I'm gonna go down there right now. We really appreciate feedback here at Google. Hopefully you all realize that we really actually, if you submit a bug, somebody sees it. And I've +1'd and echoed bugs that have come in from the outside. So please, please, please give us feedback that not only goes for bugs with our products, but also for our sessions. So if you have a minute, please go ahead and give feedback in the app. We'd really appreciate it. And with that, I want to thank you all so much and say enjoy the rest of the week.